As an application example, we focus on the gain function of an RC circuit. A very basic and common example that you encounter in a lab experiment is to measure the amplitude of the output of an electric circuit to a sinusoidal source over a range of frequencies. Typically, a simple RC circuit together with a function generator and an oscilloscope are used to conduct this experiment. To obtain the gain function in several iterations, we measure the amplitude of the output waveform as we change the frequency of the input signal. In this application, to simulate this experiment, we use the differential equation modeling the RC circuit, as shown here. Here, x of t is the input voltage and y of t denotes the output voltage. Without loss of generality, we can set the value of RC, the product of the values of the resistor and the capacitor, equal to 1. Now, having this RC circuit and the differential equation modeling the RC circuit, let's plot an estimate of the amplitude of the output signal when x of t is a sinusoidal function equal to sine of 0.5t. Note that the horizontal line here shows the amplitude of the output signal. Now, if we repeat the measurement at the frequency omega equal to 1 radian per second, we have the output signal as shown here. Let's run the measurements 2 more times for frequency omega equal to 1.5 radian per second. We have the output signal as shown here, and when omega is equal to 2 radian per second. Now that we have these measurements, we can gather the measured amplitudes and display them in a table. And of course, we can plot the actual gain function of the RC circuit and show these measured values that we obtained for comparison on the plot of the gain function. In this application, we considered a laboratory experiment where the amplitude of the output of an RC circuit to a sinusoidal source is measured over a range of frequencies, and we simulated the experiment using the differential equation model of the RC circuit. We obtained an approximation of the gain function by repeating the measurements for different values of the frequency of the input signal.